Good morning, everybody. Thank you to the Society of Letters, Technologies, and Chemists for giving me this opportunity. It's a great honor to be here. It's a long history of the conference and long history of the school. So I feel very, very lucky to be here. I will spend only a few minutes to talk about Elementis. Elementis is a public, London-based company. We have 4 business units represented on the left. One is the personal care. The next on the right top is the coatings. And then in the bottom is the energy. And then the last one, but not least one, is the chrome, which is where I'm here from. The intention of this presentation is to share with you what we do to develop when we develop new chromes. And we have the great presentation about the history of the leather, and the good news is that we see that the industry is here to stay for longer time. So a lot of the articles that were presented here, they were made with chrome in some part, right? Some of them may be at the beginning vegetable tanning, but there was some time when chrome was introduced, and still today is the most the material that is used to tan the most leathers in combination with the wet white and the vegetable tanning. So when we did this work 2 years ago, we were preparing ourselves in Elementis to be ready for the new regulations coming about the wastewater treatments, the specifications for chrome discharges, not only in the US where we are based, but also covering Mexico, and in some ways contribute to the industry around the world. When we talk about Elementis, we have the chromium division is based in the US. We have 5 facilities related to the chrome, but 4 of them we start our process in Wilmington, North Carolina, when we receive the chrome ore from South Africa. And in Wilmington, we do the conversion from the chrome ore to the sodium dichromate. From there, we move the sodium dichromate to 3 facilities located on the Midwest of the U.S., where most of the cattle is located. So we have the production plant in Milwaukee, Wisconsin. This is where we have the lab testing also that we provide to our customers. And then we go to Dakota City, Nebraska, and then we cover Amarillo, Texas. From here, from Amarillo, Texas, we also are doing our business in Mexico. So this is the agenda for today. We have I did this on the school way to do the projects. When we put what is the objective and the theory, we will go through some hypotheses and the procedure to see the lab results and make the conclusions of this project. As I was telling you, this work is only one piece that we use when we start to develop new chromes. We call differentiated chromes, which are intended to improve the chrome penetration, the chrome fixation, and still provide the color and the specifications that are required by the wet blue producers. This topic is specific for basicity. In addition to the percentage of basicity, we also determine, we have to introduce some ligands, some materials that will make these chromes more reactive and to give the better performance. So this topic will be exclusive for basicity. When we talk about basicity, most of the times you hear about the 33% basicity, but we say, okay, but what happened on the 20? What happened on the 50 or on the 60? So the The advantage that we have in Elementis, I forgot to say that the chrome that we produce in the US is liquid chrome. So we have the advantage to produce it in small sites close to the tanneries. So when we receive all our raw materials in liquid, the sodium dichromate, the sulfuric acid, and the sugar. We have an organic reduction. And from there, we make the reduction, and all the final product leaves our facility in bulks. So there is no packages involved during the process, and we don't give any package to the customer. We supply the liquid chrome and we put it in the tanks, and from the tanks, they feed their drums. To sometimes they go by level, which correlates with the weight, or sometimes they have already the screens where they put the weight that they want to transfer. This is the way how it's used in the US. We have 90%, around 90% of the US market. The US market is really defined by 10 big tanneries that has all the wet glue, or most of the wet glue production in the US. Well, when we talk about the basicity, we talk about the relation of the OH groups to the total amount of chrome. But to put it in a simpler way, to look the basicity, as we increase the basicity, we are talking also about an increase of the pH. So really, the pH is something that we can measure very quick when we have the process. We take the pH reading, we will see how basic or how acid the float is. So starting from here, when I talk about basicity, we will be talking also directly about the pH. This is some of the theory, and you may know Dr. Anthony, very respected person in the leather industry. And when we go to the books and he talk about basicity, he say when we have at the beginning of the process, the tanning process, we have a low pH, we're talking about, and low temperature, we're talking that the reaction rate will be slow, so the chrome will go there, but it won't be fixed. The penetration will be very fast. Then when we start to do the basification process, when we start to raise the temperature and start to raise the pH, we are modifying the reaction rate now will be very fast, and the penetration rate will be slow. So wherever it went into the high, it will get fixed once we start to increase the temperature and the pH. The other theory that we have is, as we increase the pH, the ratio of the chrome in the float and the chrome uptake will be increased. So this is basically what we do in the tanning process. We start to increase the pH to get the chrome fixed. We want to have the chrome in the wet glue, not in the float. And in the bottom is a very simple way to describe. When we talk about basicity, we're talking about small circles, and compared to the big circles in the 60% basicity. Again, I just want to make sure that the 50-60%, especially the 60, is something that you may not hear in the market, but we made it just to demonstrate what happened if you use that percentage of basicity. And in summary, these are the hypotheses that we're trying to prove on this project. Is as we decrease the basicity, we are increasing the penetration. The opposite, we will increase the fixation as we increase the basicity. And we're going to see if the range of 30 to 40, which is what is normally used 33 or 42, if that is the optimum range, and why we are on that range. So, and also the pH of the wet glue. pH of the wet glue, as we increase the basicity, will go higher. Something new that we included here, that's the reason why we're making these new chromes, is something that is called unfixed chrome, or is called a free chrome, which is basically represents when the process of the wet glue production is completed, we put the wet glue as we test the pH, which is grinding and put it in water. Then we collect the water and we analyze that in a ICP or atomic absorption. We analyze that for the total chrome. This is very important now because countries like China, when they have at the beginning they were maybe not regulations or very tough regulations for the chrome discharges, but once they start to put the chrome regulations like 10, 20 ppms, the unfixed chrome becomes very important. And why? Because in the US, 90% of the wet glue made in the US is exported to China, Europe, or so. The unfixed chrome is critical because when the wet glue companies pack the wet glue and ship it, the wet glue spend, let's say, 2 to 3 months in the boat, and then the first thing that the companies do when it arrives to China or Europe is they soak it in water in order to start the process again, to do the ringing, the splitting, and the shaving, all the process. So this is the unfixed chrome test simulates what is happening the first time that the wet glue is immersed in water. This is the summary of the procedure. So we will prepare, we prepare 5 different chromes, 20, 30, 40, 50, and 60. We have this capability in our small lab in Milwaukee. Then what we did is we focused this to American Heights. We did all this development in León, Mexico. This is where I'm from, and this is where we have our laboratory, when we can do the R&D work for the US and Mexico. What we did is we did the steps from soaking to deliming, to lime, under production conditions. And then what we did is we started deliming pickle in a single drum to prove every basicity and under the most similar conditions, as close as we can, starting from similar deliming pickle, so we can have only the variation of the tanning material at a different basicity, doing the same time, same addition of basifier. Just let the difference will show the difference between the basicities. We collected wet glue and float samples, and we use ASTM methods to do the chrome oxide content, the pH, and we use a draft of that is under preparation for the ASTM for unfixed chrome. So it's not official. I'm part of the ASTM committee, and we are very close to have an official ASTM. Now putting some pictures to the procedure. We started here with the American salted hides in León. We run all the beam house in the production scale, and then we have here our lab in León, Mexico, and we did the wet glue ringing also. Now we went back to the production conditions, and then we did the wet glue testing. This is the beginning of when we start to see the data. As you can see here, we started from similar pH of the pickle. We applied, which is a practice in the US, and most of the tanneries, they apply 30 minutes of 1% sodium formate before the addition of chrome. And then we ran 30 minutes, we checked all these are pH readings. Then we went to 90 minutes, 2 hours, and then after 2 hours we start to add the megas. We use magnesium oxide as a basifier. It's also what is used in the US. Then we start to increase the temperature. We started with 77 Fahrenheit, and then we went to 100, and we ended at 122. So we did 270 minutes. The first highlight that you see here is the basicities 50 and 60. They start to separate from the rest of the group, right? Which makes sense. I mean, these are some of the nightmares for the tanners when they start to see the pH going very high like this. You know what is the result of the color of the hides, right? And sometimes in the chrome content. Then we took the hide, the wet blue, and the first evaluation that we did was to have the total chrome uptake. And you can see, especially on the extremes, we can see the 20% basicity have a 3.25 and the 60% has a 4. So it's a point of 0.75% is something that we consider something to have it's a difference in the process, and it can make the difference of passing or failing the specifications. We can see here between the 34 and the 40 we have no significant difference. Even here now from the 34 to the 50 we have now 0.4, around 0.4 difference, which is when we start to see something that to put attention in as a difference in the result. Now, the previous slide was the full thickness. What we did now is we're trying to see how is the penetration. So we took the wet blue and we split it in two layers, a grain and middle. When you see the chrome in the grain layer, the differences are bigger, are more evident, because you see here now going from 3.2 to 6.7 is huge, but you can see the reactivity of the 60%. It was very big. Even on the 34 to 40 on the grain, now we start to see a 0.5. Now the opposite will be on the middle layer. The 20% will penetrate more than the 57%. So what we see here on the trend lines is what we were talking on the theory and sometimes the hypothesis that we're trying to prove. It's important here to mention that these numbers are every test we ran was two sides. So we tested two different sides and what we are showing is the average. Here we talk about the unfixed chrome. So when we saw in the first slide, the 20% looks like it has very good chrome uptake, but what we see here is that it's not the best for the unfixed chrome. And what this tell us is that the 20% may penetrate more, but if you run it under the similar conditions, you will have a risk of having a lot of unfixed chrome. So now what you can do here, we say, okay, you can extend the time to get this fixed. I mean, this is a solution, but for the purpose of this study is we run everything under the same conditions, no extra time for any of the tests. Now, when we see the pH, you can see the pH is also making sense with the theory that as we increase the basicity, we will be increasing the pH. And the final is the color, the wet blue color. You can see here, sometimes pictures don't show exactly, but what you can see here is on the 60%, the color was really green. And this is what I call the nightmare for the tanners. When the pH is increased very drastically in the drum, is when the basicity went up and the chrome got fixed on the surface, and this is giving the blue color. So in the computer you can see it better than on the screen. And you can see here the two sides. These are how we market each side to have the traceability from the deliming to the end of the process. The conclusions is that when we start to develop the new chrome sulfates, we prove the theories that between 33 to 42 we have the balance of the chrome penetration, the chrome fixation, and the unfixed chrome is also acceptable. So based on this work, when we develop the new basic chrome sulfates, we consider this information that we got out of this project. We consider this to say this is the basicity that we want to try. So now we have new products with a 38% basicity, which we say, okay, we will get a little bit more of the chrome fixation than the 34, but we won't be as very high or drastic fixation as the 15. So we are keeping our range between 38 to 42, or in this case 33, because we have to keep one standard. These results, we are using this, and we created 2 new products, and these are 2 new products that we have for the US market. And this is the first development for the company in the last 20 years. And Milwaukee used to be huge in the tanneries, tannery center, and then the tanneries in 1970 went down, and only 10 companies. So in the 1970s in Milwaukee, I was told that we have 50 different chromes for each company. They were asking. Then when the companies left, we have to concentrate and have maybe 5. Now we won't be back to the 50, but we are targeting at least to get 4 more, and targeting the chrome penetration, chrome fixation, and keeping the same quality and the reputation that we have in the US market. I want to say thanks to the company Elementis, Joe, our partner in León, Mexico, and to the technical committee of this association. Present here. I don't know if we have time for some questions.
Right. Thank you, Jose. Thank you. Has anybody got any particular questions for Jose? Yes, we've got 2 gentlemen here. I'll choose the one at the back. Is it good in hand?
Thank you very much for the presentation. I've got 2 questions. One thing is, what is the concentration of your product? You said it's a liquid chrome. And the other question that I have is, if there is any possibility of enhancing penetration of the highest specificity, which you refer as 60, that means there wouldn't be surface fixation. I work for Zeros, and we have the polymer beads technology. Principally, that technology is used to enhance penetration and cross-section of uniformity. So in that case, we might possibly use that chrome, which is high specificity, and be able to produce a good wet glue. So have you tried to look at any other possibilities of enhancing penetration of the high specificity?
Okay. Yes, the first question is the concentration of our liquid chrome is 17.5. The chrome oxide content. The second is, the first phase is, when we did this, we started with almost 20 different products, like the funnel system, to come to 2 new products. Now we are, based on these 2 new products, we are starting to make the variations, right? So we are on the second step, when now we say, okay, what we learn from here, that you say, is 60 is very reactive. Now how we can enhance either the 60 to get the penetration, or the 34 to get the fixation, right? To get an improvement. So we have the advantage, we have the kitchen at home, and we will be very open to work with you and the development of new and enhanced chromes. Yes, we are ready.
Yeah, great, thank you very much. For your information, in the afternoon, our director would be here to give a bit of presentation at the end of the session, so you might be big on to discuss about it as well.
It sounds great. Thank you.
First of all, Jose, thank you for your presentation. Found it very interesting. Have you any comments on the hydrothermal stability of the samples that you produced during the process? Because as the one-time wet glue plant manager, we always worked by the strength of the boiling test. I know that in León and in other places in the world, boiling happens at sort of 93, 94 degrees C due to the elevated location of the hydrothermal stability is one of my questions. The other is, have you any comments regarding recovery and reuse of the enhanced chromes in terms of a closed-loop management system? Because, of course, we all realise that the best way to keep chrome out of the effluents is not to put it there.
Yes, for the stability, it's something that we didn't present it here, but I can tell you when I was running, because I did this personally there, when we were checking the boiling test in Leon, in this case, the temperature was around 94, 96. We saw that the range from 30 to 42 was acceptable. But when we go to the edges on the 50, 60, it starts to shrink. Yes, not to say the 10%, but it could have a 5% or more than that. Sometimes the 3% is what they call acceptable. Yes, it's something that we can also include in the next review, right? In the next projects. For the chrome recovery, I totally agree. This is part of my job in the US. 90% of my technical service is dedicated to the chrome recovery because we want to have chrome out of the news. We want it on the wet loop. And this is something that we take in consideration because, especially in the US, the chrome recoveries, they are used to these liquid chromes. And when we develop new chromes, we also need to check that there is not an impact on that, right? That we add materials to make this more reactive, but materials that they are not harmful to the wastewater or to the closed loop. Yeah.
Because the recovered chrome needs to be equally as effective
Exactly.
as the original chrome.
Yes, so yeah, that is the part that we also need to be very careful. We cannot add materials that can be restricted, listed on the restricted substance list. Yeah, totally good one. No.
Really? You brought it with you.
Just to clarify my understanding, you mentioned in your production process the sugar. It is the vast majority of your products reduced by the glucose, or do you still produce an SO2 reduced product?
No, what we have is totally 100% organic reduction, but what we have is the purity of our chrome is, because we use the dichromate that we use is not only used for the basic chrome sulfate, we use it also for the plating. And especially on the plating industry, any organics, it would be very bad. So sometimes when people hear about the organic reduction, the first word that comes is it has a lot of organics. When we did some analysis against standard chromes that are SO2 reduced, we find that we have less organics in the composition because the way that we manufacture the product.
Sure. My further comment on that would be, with the experience of tanning with both systems, is that the glucose reduced or the organic reduced material is more susceptible to mold growth.
Mm-hmm. We don't have that reported in some ways. I mean, what we have is, having this history in the US. I mean, of course, sometimes there are some issues, but when there are issues, they are not directly related to the chrome use. Sometimes it's more the conditions, moisture, temperature, other factors, yes. Mm-hmm.
Elton from Buckman. Jose, thank you for your paper. With the increased focus on chrome and chrome issues, penetration and fixation is becoming more and more important. A lot of chemical supply companies, including our own, are looking at masking agents to be able to work with high basicity chromes and also reduce salt and acid in tanning. Are you looking at all of that, and any reason why you are not looking at masking agents?
We are looking to that, Dr. Anton?
Yes. So what are your thoughts on that?
No, I think the industry, we want to keep chrome out of the news, and we want to be part of that. We have the chemist in our division. He's looking through all the options. So the masking agents is maybe the key part for us. I mean, we're trying what we are capable to do inside, and we are maybe ready for the next step to approach companies like yours to say how we can partner, to say you may have the chemistry and we have the chrome, so how we can blend that to deliver a system. We're working more one chrome or one system. For us, the ideal is something that we can incorporate during the reaction, but if we cannot do that, we can see how further we can go this. And the other step is how we can partner with companies to include some masking to say, okay, when we put this before, after the chrome, in combination with chrome, how this will react. So yeah, I have the relation in the US with Marcelo there, and I think we are on that point to start that conversation.
Thank you. I think the good news is we can solve these problems technically, but the tenders are going to ask us the cost, right?
Yes. Yeah.
Thank you, Arthur.